Yes, hello from Chris, and welcome back for our chemistry lesson, the 12th lesson since we started this program. And today we are going to look at what we call, Lussac'S law. Yes, we are going to look at what we call the Lussac'S law. Now, so we have Lussac'S law. Lussac'S law. So this is what we are going to learn today. So, what is this Lussac'S law? Now, at the end of this session, you are supposed to be able to state Lussac'S law and also apply it in working out calculations. According to Lussac'S law, when gases combine, they do so in volumes which bear a simple ratio to one another and to the product if gaseous, under standard conditions of temperature and pressure. So, when gases combine, meaning when gases react, they do so in volumes. So when gases, meaning this law applies only to gases. So when gases combine, they do so in volumes which bear simple ratios to one another and to the product. So if, for example, we have gas A reacting with gas B to form AB, then we can say that when these gases combine, they combine in volumes. For example, 10 centimeters cubic can combine. Let's take this example that we have 1 mole of A, 1 mole of gas B, giving us 2 moles of gas AB. Let us take volumes. One volume requires 1 volume. 1 volume of A requires 1 volume of B to form 2 volumes of AB. So we can say if we have 10 centimeters cubic, this 10 centimeters cubic will require 10 centimeters cubic because 1 is to 1. So if this one is 10, this one must be 10. And then here is 1 is to 2. If this one is 10, then this one will be 20 centimeters cubic. So we can say 10 centimeters cubic of gas A require 10 centimeters cubic of gas B to form 20 centimeters cubic of AB. Now I'm going to remove this. I'm going to remove that so that I remain with volumes. And then we are saying when gases combine, when gas A and gas B combine, they do so in volumes. So 10 centimeters cubic combining with 10 centimeters cubic, and these volumes can be simplified into ratios, whole number ratios. So you can simplify these volumes into ratios. If you simplify this, you'll have 1 centimeters cubic, 1 centimeters cubic, and 2 centimeters cubic. So we can say what? That these gases, they combine in the ratio of 1 is to 2. So we'll say this one is 1 mole to 1 mole to 2 moles. In other words, the volumes can be simplified to represent whole number ratios. So this is 1 mole of B, 1 mole of B, 2 moles of AB. So from the volumes we can actually come up with the mole ratios. That is Gay-Lussac's law. Let us see how can we apply applications of Gay-Lussac's law. So we are going to look at how to apply Gay-Lussac's law, and our first example we are told at 20 centimeters cubic at 20 centimeters cubic sample of butane, that is C4H6, is burnt in 150 centimeters cubic of oxygen. And the equation is given: what volume of oxygen reacts? Yes. Now, butane. So this is number 1A. Butane is C4H6 plus, so we have 2 there, but let me show you how to balance this equation. You need to know how to balance it. So plus oxygen to give us CO2 plus water. Now this is an organic equation representing the burning of hydrocarbons. Hydrocarbons are compounds made up of carbon and hydrogen, and whenever you burn hydrocarbons in air, you get carbon dioxide and water. In balancing organic equations, the first thing that you should do is to balance carbon. 4 carbon, 4 carbon. You make this one 4. 6 hydrogen, 6 hydrogen. 3 times 2, 6. Then finally, balance oxygen. Oxygen this side is 2. This side we have 4 times 2, 8. Here we have 3 times 1, 3. These are 11. So, which number, when we multiply by 2, we get 11? It should be, if you want a number that when you multiply by 2, you get 11, it is 6.5. 6.5 times 2 is 11. And 6.5 is the same as 11 over 2. So we are going to have 11 over 2. Then we remove the denominator. So for us to remove the denominator, you multiply everything here by the denominator. And the denominator is 2. So when you multiply everything here by 2, 2 times butane, you get 2 butane. 11 over 2 times 2, you remain with 11 O2. 2 times 8, 4, you get 8 CO2. 2 times 6, you get H2O. So this one is the equation for our reaction. That is how this equation is balanced. So that's how we balance this equation, but I need this space. So let me just have the equation up here. So that is our equation, which is 2, 11, 4, 3, like that. Gas, 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 liquid. Take note that Gay-Lussac's law apply only to gases, not liquids, not solid. According to this law, gases, based on this law, gases are assumed to be occupied 0 volume. Even solids are taken to occupy 0 volume. We come back here. So from this equation, we are going to say 2 moles of butane requires 11 moles of oxygen to give 4 moles of carbon dioxide and 3 moles of water. Good. We come back. Then we say the ratio of butane to oxygen, we can try it here. When we take butane to oxygen, the ratio is 2:11. 2:11. But we are told that 20 centimeters cubic of butane, so 20 centimeters cubic. So if you have 20 centimeters cubic, what volume of oxygen will be required? So in this case, we say if this one is 20 centimeters cubic, then if 20, if 2 moles represent 20 centimeters cubic, 2 moles represent 20. What about 11? So 11 moles will represent what? So 11 times 20 over 2. So this one will be 110 centimeters cubic. So the volume of oxygen here will be 110 centimeters cubic. That's the volume of oxygen. Now, the whole volume of oxygen reacted. Then part B, we are told what volume of carbon dioxide will be produced. So we say if 2 represent 20 centimeters cubic, if 2 moles represent 20 centimeters cubic, what about carbon dioxide? So carbon dioxide is how many moles? 4. 4 moles will be what? It will be 4 times 20 over 2. This one will give us 40. Is it? Yes, 40. So it will be 40 centimeters cubic of carbon dioxide. 40 centimeters cubic of carbon dioxide. Then let us leave it there and then we continue in the next segment.